Okay, so I'm going to go through some of these questions. You'll notice that these ones go quicker than the other units for questions. Sometimes like one question can take a long time. These ones are pretty quick. So even though there's a lot of questions, it shouldn't take too long. So number one is each angle theta in standard position. Explain. Well, standard position was coming from our initial arm, and then up to the terminal arm. So remember when it comes up this page. So terminal arm, and then reference arm. So yeah, pretty much looking at that, you can see that this one would not because this actually doesn't come to the origin, right? This needs to be back at the origin there. This one is. You can see it goes as the initial arm to the terminal arm, and it's going to the origin there. This one doesn't start at the initial, so it's not, but this one would be as well. So yeah. Okay, so matching these ones up here, we've got 150 degrees. What could that be? Well, 180 would be right flat, right? So if I, had the line going straight across this way, that'd be 180. So it's got to be less than that. So it's got to be something kind of pulling up in this quadrant. So yeah, it's got to be F. So B, 180, well, that's just going to be straight across. So that's C. 45 degrees, that's going to be, where is that? This one there, A. Just 45 is up like that. D, well, 360 would be all the way around. It's not quite there, so I'd say 320, that would probably be D. And then 215, well, 270 would be straight down. So it's got to be less than that, so I'm thinking it's got to be B. F, 270, well, 270 is straight down like this, so that'd be E. So that one there. 3. In which quadrant does the terminal arm of each angle in standard position lie? So I'll let you guys kind of go through and do that one. It's similar to the ones we did up there. Just make sure, I guess, that you remember that this is quadrant 1, 2, 3, and 4. And I'll let you do 4 too, and there'll be a picture of that in the back of the book too. Yeah. Let's do 5 quick though, I guess. So let's do 5, and let's do 5D. So 215 degrees. That means from this arm, from like the positive X part of the Cartesian plane. So 215, so I keep going around, 100, past 180. I'm not going to get to 270, so it's going to be in this quadrant. And it's going to be going down like this, right? So that's the arm we're looking at. And it says, what's the reference angle? So it wants to know what this angle is. So all I need to do, I know that from here all the way to there is 215 degrees. So if I want the reference angle, I need to go 215 minus 180. And that'll give me what's left from there to there. So your reference angle is going to be 35 for that one. Okay, so the other ones will be similar to that too, but yeah. Yeah, I'll move on. Okay, 6 here, what it's saying is that you've got a Cartesian plane, and let's say we've got the first one was 45 degrees. So 45 degrees would be, out like that. And so this is 45 degrees. It says determine the measure of the other 3 angles in standard position. So the other ones that would have a reference angle of 45 would be out like this, where that's 45. I know that's not really the same, but ideally it should be. This one would be 45, and this would be 45. But it says determine the measure of the other 3 angles in standard position. So what it wants is the angle from there to there, which we already know for the first one's 45. But then for the next one, it would be from this arm to there. So how would you find that? Well, you would just go 180 minus 45. And that would give you this angle. The next one, you would go, it's still going to be from here, but now to the red arm. And to do that, that would be 180 plus 45. And I'll let you guys figure out what that is. And then the green one, again, so it's coming from here. It's going to go all the way around to that point. To do that, I'd say that the easiest one there would be 360 degrees, because that'd be 360 all the way around, right? Minus 45. And that would give you that one. And they're all going to be similar type questions to that. So, okay, so number 7 is going to be similar to the one we just did above too. So let's do the first one here. So in quadrant 4, so that's down here, it's saying that the reference angle is 72 degrees. What's the angle in standard position? So it wants to know what is the angle from here to there, all the way around. So again, to do that, I would just go 360 degrees minus 72 degrees. And again, I'll let you guys do that. And then, yeah, so they're all going to be similar to that. So, okay, so this one now. Part A says, determine the coordinates of the trees that Paul and Gail wish to plant. So I'm just going to write it right on here. Well, if this coordinate is 3.5 and 2, this one over here would be just negative 3.5 and 2, right? Because this is the x coordinate, this is the y coordinate, right? This one down here would be negative 3.5 as well, but then it's down now, so it's going to be negative 2. This one is going to be positive 3.5, and it's down, so negative 2. Okay, so for B here now, it says determine the angles in standard position if the line drawn from the house to each of the trees are terminal arms. Express your answer in the nearest degree. All right, so what we got to do, I'm going to zoom in even a little bit more here. If we figured out what this angle here was, then that would be our reference angle for every one of these things, right? So let's figure out what that is. But first, let's draw a triangle out of this thing. So I know that the blue part here that I've just drawn, that's going to be 3.5. The green part that I've just drawn, that's going to be 2. So if I want to figure out what theta is, I can say, tan theta. Oh, here, just so you know where I got tan, I guess, from. If I look here and say, okay, SOHCAHTOA. Tan deals with the opposite and the adjacent. Well, the green one here is my opposite. The blue one is the adjacent. So that's what I need to do. So it's going to be tan theta is equal to, the opposite is 2. The adjacent is 3.5. Next step, I'm just going to go theta is equal to tan, or the inverse of tan, of 2 over 3.5. So theta is going to be equal to, it's going to be 29.7. What did it say to do it in nearest degree? So let's even just go 30. So this is 30 degrees. Okay, so now if that's 30 degrees, I can pretty much say that this is 30 degrees everywhere here, right? 30, 30, 30, and 30 degrees. All my reference angles are the same. Okay, so now all you got to do is figure out what the angle is from your starting point to that one. And then what is the angle to that one? And then what's the angle to, bring out the colors, that one. And then that's it. So the same method that you were using up top. So I'll let you guys go ahead and finish that one. Okay, now looking at the questions on page 96, it says sketch an angle in standard position so that the terminal arm passes through each point. Okay, so for these ones, let's do C. So this one here. So I'm just gonna briefly sketch it. So I'm gonna go over around, like, 5 to the left because it's -5, and then -2 down. So let's say our point's like right there. So this point is at -5, comma -2, and comes from the origin. And what we're after, doesn't matter how long it is, it could just go right to that or stop right there. Now what we're after here is this angle from there to there, right? Because it's in standard position. But to do that first, we're going to have to find the reference angle. So let's find the reference angle here. And the way we can find our reference angle is by kind of turning this into a triangle. So if we drew a triangle down here, and we'll make the other x component of my triangle there, I know that the red part here, my y component, that's -2. I know my purple part, or my x component, that's going to be -5. So I want to figure out what this is. And for the most part, actually, we don't even really need these negative symbols anymore, right? Because the fact that they are going to the left and going down, that's all we really need. So you can kind of drop those when you draw your picture like this. It's going to be 5 to the left and 2 down is what the most important part is. So if you do that, we can figure out what theta is now, because if we go back to our SOHCAHTOA, I know that I have to use tan because I have the adjacent side and I've got the opposite side. So I can start writing tan. I'll write this over here. Tan theta, which is what we're looking for, is equal to opposite over adjacent, so 2 over 5. Now if I want to find theta, I'm going to go theta is equal to tan -1, 2 over 5. And then theta is equal to 21.8. So let's just say, to make things easier, let's say 22. It didn't actually tell us what decimal we needed to be exact to, so 22 degrees. So I know theta is equal to 22 degrees. Now if I want to figure out what it is in standard position, then that's just going to be the angle from here to there. So 180 degrees plus my reference angle theta there is going to be equal to, so 22 degrees is equal to 202. So that's how you do those. So the sketch would be of this, and then this would say 202 degrees. All right, so number 3, this is a pretty common one. So let's do B, I guess. So we'll start with that one. And it says that's at point -12, -5. And it says we need to find the exact trigonometric ratios of sine theta, cos theta, and tan theta. Well, what we're going to do, if I zoom in again here, we can, again, draw a triangle out of this. We can go, okay, this side and this side here. And I know that going down, that's going to be -5. So I got like 5 down. And going to the left there, oh, maybe I'll make that red. So 5 down, and then blue, we're going to have 12 to the left. So that's 12. So what we got to figure out is really what, so this is theta. We need to know what this is though, like what's our hypotenuse on this thing. And let's put, let's leave the negative symbols on there for now too. You can leave them, it doesn't really matter, right? But leave them. And why, I'm going to show you why we need that though, why we need the hypotenuse. It kind of, you can look back to our SOHCAHTOA again. So SOHCAHTOA. So as of right now, we can figure out the tangent identity, right? Tan theta. We can figure out that right now. We don't even need the hypotenuse because tan, I can just say tan theta is equal to, and that's equal to opposite over adjacent. So I could say -5 over -12, which is the same thing as just tan theta is equal to 5 over 12, right? Because the negatives just cancel. So that one's already kind of done. But if I want to do sine and cos, they both have the hypotenuse involved. So we got to figure out what the hypotenuse is before we can do those. Okay, so that one's done. Now we just need to figure out what the hypotenuse is. So hypotenuse, I'm going to say c squared is equal to a squared plus b squared. So c squared is going to be, you can leave the negatives there if you want. There, since it's squaring, it doesn't really matter. But so I can say 5 squared plus, what was that, 12 squared. So C is going to be equal to the square root of 25 plus 144. So C is going to be equal to 13. So since I know now that this is 13, now we can just really use our trig identities up here, our SOHCAHTOA, just to kind of plug in as you go. So the next one here is going to be sine, let's say. So that's just going to be sine is equal to, sine is opposite over hypotenuse. So that's going to be -5 over 13. And remember, the hypotenuse is always positive, right? We call that terminal arm. We always call that positive. So -5 over 13. And the negative does matter here because that's saying that now we know that it's going to be in that quadrant. Well, I guess technically it could be in two different quadrants, but okay. So that's that one. And then lastly, we'll do cos. So cos theta is equal to adjacent over hypotenuse, so -12 over 13. So then that'd be it. Okay, so hopefully that made sense. You guys will need to make sure that you're able to do these because it's a pretty common question. All right, moving on. Okay, so number 4 here. It says, for each description, in which quadrant does the terminal arm of angle theta lie? So what I would suggest doing is writing down cast. So this is pretty much saying cos theta is less than 0, so cos is negative. And sine is greater than 0, so sine is positive. So what you can kind of do if you're just looking at this, say, okay, where is cosine theta negative? Well, looking at our cast rule, remember, cos is positive there and there, so it's negative there and there. So that's a good place to start. And then look at the next one. Sine is positive. So where is sine positive? Well, sine is positive there and there, right? So the only place that it both works out is that one. So it has to be in quadrant number 2. Right? This is quadrant number 2. Okay, let's look at D to do it one more time. So we do our cast rule. It says, okay, so the first one here, I'll make orange for tan right now. It says tan's negative. That's what that says, right? Tan's negative. So where is tan negative? Well, tan is negative there and there. Where is cosine positive? Where is cos greater than 0? Cos is greater than 0. I'll make this blue. It's greater than 0 here and there. Well, the only place that both happens is in quadrant 4. Okay, moving on to 5. Determine the exact value of sine, cos theta, and tan theta if the terminal arm of the angle in standard position passes through the given point. Okay, so let's just do A. So it starts out with, so -5, 12. It's going to be some like up here. Okay, so this point is -5 and 12. Well, we can make this into a triangle again, knowing that this will be -5 and this will be 12. Okay, so we can draw our angle here. It does say it's in standard position, but that doesn't really matter for us. It's going to be the same values of sine, cos, and tan. Like, it's not going to change. So what we need to do first, though, is figure out what that hypotenuse is again. So to figure out that, we're going to go c squared is equal to a squared plus b squared. So c in that case is 13 again up above. Like, so if you do a squared plus b squared. So this is 13. So if we want to figure out what sine, cos, and tan theta are, well, we're good to go now. So if you want to know what sine theta was, well, sine theta. So sine is opposite over hypotenuse, so that's going to be 12 over 13. Cos theta is adjacent over hypotenuse, so that's going to be negative 5 over 13. And tan theta is opposite over adjacent, so 12 over negative 5. That could just as easily say negative 12 over 5. Just so you know, people kind of, yeah, get that confused sometimes. Okay, so those would be the answers for A. In the back of your textbook, it says for answers too, like you get some like different kind of, well, here, I'll show you. Let's do 5. Actually, I'll just kind of show you what they did. So let's say for number 5B, it says one of the answers for sine theta is, let me just write this over here. It says one of your answers for sine theta for 5B is sine theta is equal to negative 3 over root 34 or 3 root 34 over 34. So just as a little bit of a review of things we've done before, why does that make sense? Well, it's because the way they got to that second number is by rationalizing the denominator, right? So remember doing that, how we didn't want to have a square root in the denominator, so we multiply the top and the bottom by 34. If you do that, then that would be equal to negative 3 root 34 over just 34. So that's what they did there, just so you're not confused by that. Okay, number 6. Without using a calculator, state whether each ratio is positive or negative. So again, what I'd do is I'd start with the cast rule and say, okay, sine, and just kind of sketch it out really quickly. So sine 155, so that would be in this quadrant, right? It's not quite 180. So according to the cast rule, sine's positive in that quadrant. So I know right off the bat that this is going to be positive. B, cosine 320. So that's going to be down here. It's past 270, so somewhere down there. Cosine in that one is positive, so that's also positive. If I look at C, tan 120. So 120 degrees would be over here. And that's negative there, right? Tan is only positive in quadrant 3 and quadrant 1, so it's negative there. Cosine 220. So 220, it's not quite to 270, the straight down one, so it's going to be in that quadrant. And cosine is negative in that quadrant. So there you go. Okay, 7 says an angle in standard position such that sine theta is equal to 5 over 13. Sketch a diagram to show the two possible positions of the angle. Why would there be two? Well, it's that whole cast rule thing again, right? So what I would do first is kind of sketch out your cast rule thing and say, okay, sine theta. And what I'm looking at first is a sign out front. Is it positive or negative? Well, it's positive, so there's two places that sine can be positive. It's going to be there, and it's going to be there. So those are the two possibilities here, right, that I'm dealing with. So maybe I'll just sketch this a little bit bigger now that I'm done with those. Oh, pen's messing up. Okay, so that's first, like, just lightly where it's going to be. Now the next thing I do is I kind of write out SOHCAHTOA, and I probably only need the so part of it because that's the sine, like this is sine theta. So is opposite over hypotenuse. Let's draw a triangle here and just kind of sketch things out lightly. So there and there as well. So opposite over hypotenuse, if this was my angle theta, opposite in this case, looking at this, is 5. So this is going to be 5. Hypotenuse is going to be 13. So this is 13. That's also going to be the case over here. So 13 and 5. Okay, so that's kind of our light sketch there. Now it says for B, it says determine the possible values of theta. Well, let's just actually do the sine ratio now. So sine theta is equal to 5 over 13. So theta is equal to sine -1, 5 over 13. So theta is 22.6 degrees. So let's say theta is equal to 23 degrees. All right, so that's the first one. We've already kind of figured that out. So one possible value is 23 degrees. The other possible value, though, is going to be this one from there to there. And the way we figure that out is by knowing that this is also our other reference angle is going to be the same. It's going to be 23 degrees. So I just have to go 180 minus that reference angle, so minus 23 degrees. So the other angle is going to be 157 degrees. Okay, 8. An angle in center position has its terminal arm in the stated quadrant. Determine the exact values for the other two primary trigonometric ratios for each. Okay, so trig ratio again to figure out what we're dealing with. What did they say? Cast rule. I don't know what. Yeah, that was weird. Okay, so cast rule. Cast. So it says cosine theta is negative. So where is it negative? It's negative over here, and it's negative over here. And it's cosine -2 over 3. Remember cos. Where can I write this? I'm in a room. Let's do that. Cos is equal to, let's do cas. So catoa, it's adjacent over hypotenuse. So if I'm looking at this point, and the other key bit of information there is you would have like two different answers, right? But it says it's in quadrant 2. This is quadrant 2 right here. So I can just, for the most part, just ignore that part now. I know it's up there. So now let's make a little triangle out of this. Adjacent is going to be this side. So cosine is equal to adjacent over hypotenuse. Well, my adjacent is apparently -2. And I know it's -2 because it's negative here, but it's not going to be -3 because 3 is the hypotenuse. The hypotenuse is always positive. We always call the hypotenuse positive. So that's going to be 3. So what I need to do now is figure out what the blue part is here, what the opposite side is. So that's going to be, let's say like b squared is equal to c squared minus a squared. So b is going to be square root of 5. And don't put it as decimal form because it says exact values. If you put it as decimal form, that's an irrational number. That's not going to be exact, right? You'd have to write an infinite amount of decimals to be exact. So anyway, so b is going to be negative, or not negative, square root of 5. So now that I know that, now it's just using SOHCAHTOA, right? So now it's just starting out and going, okay, SOHCAHTOA. The other two are cos and tan, so cosine, oh no, sorry, sine and tan. So sine theta is equal to, sine is equal to opposite over hypotenuse, so square root 5 over 3. Tan is equal to opposite over adjacent, so that's going to be negative square root 5 over 2. Notice I put the negative up top. Doesn't matter. I just wanted to do it just to kind of mess with your heads. Because you'd probably go square root 5 over -2 means the same thing, right? Okay, so that's how you do those ones. So yeah, I want you guys to go or just look at the other ones. They're all pretty much the same kind of concept. So just get a lot of practice doing those. All right, 11. So I'm not going to go too deep into this one because it's a combination of just the other questions that we've done, just kind of more practice. Maybe though, just so you know, X, it's saying this part, right? So what is that? Y is going to be your up and down, and then r is your hypotenuse, right? That's that one. Just so you don't get stuck on that. So you really just got to figure out, or from looking at this, that this is going to be -8. The green one, or y, is going to be 6. And you can use your Pythagorean theorem to find the blue, or the hypotenuse there, which is r, and then do your trig ratios, so just like above. Okay, point -9,4 is on the terminal arm of an angle theta. Sketch it. Okay, so this is a pretty common question too. There will be one just like this on your test. So let's do it. So I'm going to start out with the Cartesian plane. I'm going to go like -9, so 9 to the left, up around like 4, so anywhere out there. I've got that. Let's go -9, 4. Let's make a little triangle here. Okay, so we're good to start. Oh, I'll put theta there. I've been writing theta too. You might want to write alpha. Doesn't matter, as long as you know, as long as you're aware of what you're talking about here, right? So the textbook uses alpha a lot to make sure you're talking about the reference angle, and then theta would be that angle. But I'm okay with this as long as you're explicit about which one you're talking about. So, okay, so sketch it in standard position. So there you go. That would be, for like I said, from there to there would be the angle we're looking for. What is the measure of the reference angle? So alpha, that one there. Yeah, so that's just going to be tan alpha, I guess we'll say, is equal to opposite over adjacent. Well, the opposite here is 4, and my adjacent is -9. So tan theta is going to be equal to 4 over -9. So I said theta, I mean alpha, is equal to tan inverse 1 of -4 over 9. So alpha is equal to, so when you do that, you get -24 degrees. Now what the heck does that mean, -24 degrees? Well, just if you don't panic, just think about it for a sec. If you look at your cast rule, where is tan negative? Because it said tan theta is equal to -4 over 9, so you're going to have two situations. Well, one's going to be down there, one's going to be up there. The negative that you just found in your calculator when you did it, you just found this angle. That was the reference angle. But that's okay, because that's just the same as this. That's also the reference angle there. So just kind of drop the negative symbol, and we know that alpha, or your reference angle, is going to be 24 degrees. Okay, now it says what's the measure of theta to the nearest degree? So from standard position, so that's just going to be 180 minus 24. So 156 degrees. Okay, let's keep going. So 13. I'm going to skip 13 because it's really similar to 12. So you guys can go ahead and do that. Let's do 16 though, or I'll get you thinking in the right direction here. So again, let's start off with cast. It says if cosine theta is equal to +1 over 5 and tan theta is equal to +2 root 6, determine the exact value of sine theta. So first off, let's figure out where cos is positive. So cos is positive there and there. So those are first two positions. Where is tan positive? Well, tan is positive only in that quadrant. So that's where we're at to begin with. So we're going to be looking like that. Okay. Now, determine the exact value of sine theta. So let's draw a triangle to get ourselves kind of thinking straight here. So we did something like that, right? All right, so cosine, let's write SOHCAHTOA too. SOHCAHTOA. So cos is 1 over 5. So let's say my adjacent here is 1. So adjacent is going to be 1 there. And my hypotenuse is 5. Okay, so what we should find is something to do with this in this answer too. So we don't even really need that though. Let's just kind of go back over here and say, okay, what is the blue part here? What's my opposite side? Well, so let's go b squared is equal to c squared minus a squared. And if you do that, you get b is equal to the square root of 24. Okay, so square root of 24. But just so you can kind of figure out where we got that from, remember our radicals unit. I could rewrite this as square root of 4 times 6. 4 is a perfect square, so I can bring it out as a 2. So b could also be written as 2 times the square root of 6. So 2 times the square root of 6. And then finally, it just says write the exact value of sine theta. Well, sine theta is going to be equal to opposite over hypotenuse. So opposite is 2 square root 6 over 5. Okay, sorry about the extremely long video. Hopefully you guys are doing okay with this. Make sure you have a good grasp on this stuff though, because it's you're definitely going to need to do all right on this to do well on the test. So that's going to be it for that video.